My dear students, today my topic is what is Lorentz force? Students, we all know when a charged particle enters in an electric field, is a positively charged plate and some negatively charged plates. So that is the charge here, and this plate applied electric force, repulsive force, and this charged plate applies attractive force. So the charge will rush towards negatively charged plate. So there is change in velocity of that particular charge, and that electric force, its value is equal to F is equal to QE. So the vector quantity F is equal to QE. E is the strength of the field, Q is the charge, and that is the electric field. This electric force is an accelerating force. It is an accelerating force because it produces an acceleration. So here we have the velocity is minimum, and then both the forces will push that charge towards this end, and its velocity increases. So the velocity changes, and so therefore there will be an acceleration. So that is an electric force. F is equal to QE. It means the electric force is an accelerating force and its value is equal to this. Now the second case is when a charged particle enters in a magnetic field. So these crosses indicates that magnetic field is into the paper, into the page. And when a charged particle enters in that region where the magnetic field is acting perpendicularly, so magnetic force will act on it and it will deflect that charged particle at 90 degree, and it starts rotating in a circle. So it starts moving in a circle, and that magnetic force is given by FB is equal to, we have already calculated this value, FB is equal to Q into V cross B. So B is the strength of the field, FB is the magnetic force, and it will act on that charge, and the charge will start moving in a circle as shown in that particular diagram, and its value is given by FB is equal to QV cross B. So that is the magnetic force, and the vector quantity FB is equal to QV cross B. Now students, we have the third case is there. When a charged particle enters in that region where both the fields are acting, the electric field is present and magnetic field is present. So in that particular case, in the second case, the magnetic force will also produce an acceleration, because in that particular case acceleration is produced due to change in direction. The speed, the magnitude of the velocity remains constant, but its speed, its direction is changing. So that's why acceleration is produced by changing the direction. And as far as the work is concerned, this electric force which does the amount of work done, the electric force, there will be movement of the charge and displacement is there, and electric force does the amount of work done. But in case of magnetic field, there will be no work is done. No work is done by magnetic field or magnetic force. Magnetic force does no work because it's a closed path. In a closed path, the amount of work done is zero. And now come to the third case. In the region where both the fields are present, the electric field is there and electric field and magnetic field is there. Then if the charged particle enters and it starts rotating or moving in a circle as well as moving in a straight line, so that motion is named as helical motion. Helical motion. So if the charged particle enters in that field where both the fields are present, electric field is there and magnetic field is there. So the sum of electric force and magnetic force is called Lorentz force. So as Lorentz force, F is equal to electric force and magnetic force, FB. So you will just insert the values, that is equal to QE plus Q into V cross B, where both the forces are present, I mean the electric force. So Lorentz force is the sum of electric force and magnetic force. F is equal to QE, FB is equal to Q into V cross B. So it is the sum of electric force and magnetic force, and it is called Lorentz force, students. And the unit of the Lorentz force is Newton. Students, thank you for watching.